Hello, today we will discuss about basic properties of complex number, mainly regarding its vector approach. We know very well that complex numbers lies on Argand plane. This is the Argand plane, this is called real axis, and this is imaginary axis. Suppose here is a point which is denoted by Z and its Cartesian representation be x plus iy. Draw a perpendicular, and this OA is x and Z is y. And we know very well that OZ is called the modulus of the complex number Z, which is the positive square root of x square plus y square, and this angle theta in the anticlockwise direction, that is in the positive direction, just tan inverse of y by x. It is very simple thing. Let OZ equals to R, say, then from the triangle OAZ, it is clear we get x equals to R cos theta and y equals to R sin theta. So Z, the complex number, which is x plus iy, I told you before, can be written as R into cos theta plus I sin theta, which can alternately be represented as R into e to the power I theta, where e to the power I theta is cos theta plus I sin theta. This is called Euler's formula, and we will discuss later why e to the power I theta is cos theta plus I sin theta. Euler's formula. So these are the facts. Therefore, e to the power minus I theta will be cos theta minus I sin theta. So conjugate of Z which is denoted by Z bar is x minus iy, which is obviously e to the power minus I theta. Now we shall go to the vector approach of a complex number. Vector approach of a complex number. This is the Argand diagram, Argand plane, real axis, imaginary axis. Suppose there is a point Z, where Z equals to x plus iy, that is its Cartesian coordinates are x comma y, if we join the zero complex number represented by the point O, which is the intersection of real and imaginary axis, is the real axis, imaginary axis. If we join OZ and put a direction mark on the line segment OZ, what we get is this directed line OZ. This is called is the vector form of the complex number Z. So you must remember, this is the vector form OZ. This OZ is the vector which represents the complex number Z on this Argand plane. One result is there. Let alpha equals to x plus iy, then alpha bar equals to x minus iy, that is the conjugate of alpha. Now alpha plus alpha bar equals to 2x obviously, and alpha minus alpha bar equals to 2iy. So this implies x equals to half of alpha plus alpha bar, y equals to 1 by 2i of alpha minus alpha bar. Therefore, alpha, the complex number alpha, can be written in this way: half of alpha plus alpha bar, comma 1 by 2i of alpha minus alpha bar. You must remember, this is a presentation of any complex number alpha. Now we shall discuss about the angle between two lines. In more detail, so you can say what will be the angle between two lines formed by joining 3 points. So now see, interpretation of argument of z minus alpha by z minus beta is a very important thing. All these which I am discussing now will be needed in the future course of complex analysis. We have not yet entered into the core area of complex analysis, but before entering into that area, you must have some knowledge about these things. Suppose two complex numbers, one alpha A, the point A represents complex number alpha, and point B represents another complex number beta. And there is a point P denoted by the complex number Z. So if you join PB and PA, therefore AP vector will be, now AP vector will be Z minus alpha, and BP vector will be z minus beta. Argument of z minus alpha, I must remember this thing, argument of z minus alpha by z minus beta is the angle between AP and BP. Okay. Actually, this theta is the principal argument of z minus alpha by z minus beta. This is the principal argument of z minus alpha and z minus beta. Okay, principal argument. So this theta must lie between minus pi. We know very well that principal argument of any complex number always lies between minus pi to plus pi, including pi, plus pi and excluding minus pi. So this is the condition. So theta is the principal argument. Okay. Now we shall discuss about straight lines, the equation representing straight lines in Argand plane, equations representing circles in Argand plane. Straight line, first we see straight line in Argand plane. Straight line in Argand plane. See. Suppose this is a straight line in Argand plane and here is a point Z, which is any point on this line. Suppose it is denoted by the point P and is a point A, which is denoted by a fixed complex number Z1, and is a point B, which is denoted by another fixed complex number Z2. So if these 3 points lie on this line, we can say angle between PA and PB will be 0 or pi. Now if we consider this, that PAB are not collinear, they must form a triangle. So if theta be the angle, if theta be the angle between PA and PB, then from our previous result we can write theta equals to argument of what I said before, argument of, this is the thing, argument of z minus alpha by z minus beta. Here you can see this is argument of z minus alpha by z minus beta was the angle between PA and PB. Okay, so P and PB. So this will be z minus z1 by z minus z2. Now if these 3 points P, A and B are collinear, this angle must be 0 or pi. So when P, A and B are collinear. Theta is either 0 or pi. Pi because when z is in between z1 and z2, and 0 when z1 and z2 lies on a particular side of this point. So this implies theta equals to 0 or pi. When theta equals to 0 or pi, this implies z minus z1 by z minus z2 equals to a real number. Why? Because, see, consider a complex number z which is ax plus iy. Now, argument of z equals to tan inverse of y by x. When y equals to 0, argument of z equals to 0. Argument of z equals to 0. So, argument of z equals to 0 is possible when see, argument of z is 0 possible when this theta, this implies theta equals to either 0, this theta is 0, that means this complex number in that case will lie on this side, that is the positive direction of real axis, and it may be either on the negative direction of x-axis. In that case theta will be pi. So either theta equals to 0 or pi. That is why we wrote here that z minus z1 by z minus z2 is a real number. Okay. So if it is a real number, this implies z minus z1 by z minus z2 equals to z minus z1 by z minus z2 whole bar, because we know when the imaginary part of any complex number gets 0, that is when the complex number becomes a real number, its conjugate becomes same as the original. So this is the things, z minus z1 by z minus z2 equals to, according to the properties of conjugation of complex numbers, z minus z1, z bar minus z1 bar by z bar minus z2 bar. And if you simplify it, you will get z minus z1 into z bar minus z2 bar equals to z minus z2 into z bar minus z1 bar. This implies z in z into z bar minus z2 bar minus z1 into z bar minus z2 bar equals to z into z bar minus z1 bar minus z2 into z bar minus z1 bar. So if we simplify, you will get z bar will be cancelled out, minus z2 bar minus z bar z1 minus z1 z2 bar. Okay, this is on the left hand side. All right, and on the right hand side is this term z bar will be cancelled out from both sides with this, and minus z1 bar minus z2 z bar minus plus z2 z1 bar. Okay, so this is the thing. So this implies first accumulate all the terms containing z. Here is a term which contains z, and here is a term which contains z. So accumulate these two things here, z into z1 bar minus z2 bar. All right. Next, accumulate terms which contain z bar. Here is a z bar, and here is a z bar. So minus z bar into z1 minus z2, right? z1 minus z2. Next, the other all terms, which is z1 z2 bar here and z2 z1 bar here. So this will be plus z1 z2 bar. I mistakenly wrote in this z1 z2 bar minus z2 z1 bar equals to 0. So this is the equation of a straight line. This is the equation of a straight line joining the points z1 and z2. Now, name it as 1. Now, if you multiply this equation 1 by I, multiplying 1 by I, 1, this is 1 by I, we get z I z1 bar minus z2 bar minus z bar I z1 minus z2 plus I z1 z2 bar minus z2 z1 bar equals to 0. Okay. Now, if you consider let the coefficient of z bar, which is minus I into z1 minus z2, as alpha, let minus I into z1 minus z2 equals to alpha. Alpha is a complex number. Okay. So what you get, its conjugate will be, see what will be its conjugate. Now alpha bar will be, see, conjugate of minus I will be I, and conjugate of z1 minus z2 will be z1 bar minus z2 bar, according to the principle of conjugation of complex numbers. So this will happen. Okay. Therefore, equation 1 can alternately be written as what? Alpha bar z plus alpha z bar plus r equals to 0, where r equals to I into z1 minus z1 into z2 bar minus z2 into z1 bar. This is a real quantity. Why? This is a real number. Why? Because since z1 minus z2 bar, the first term here, if you take conjugate of this, you will get z1 bar z2, which is the second term here. So we know very well, if you subtract the conjugate of any complex number from the complex number, you will get an imaginary number. So z1 minus z1 z2 bar minus z2 z1 bar is imaginary. So if you multiply any imaginary number by I, you will get a real number. That's why z1 z2 bar minus z2 z1 bar multiplied by I is a real number. That's why I wrote a real. So this is the equation. This is a general equation of a straight line. You must remember, this is a general equation of any straight line. Okay. Now, we will discuss about the circles in organ plane. Suppose here is a circle in the organ plane, and P be its center, represented by a complex number z1, and take any point on its circumference. Suppose this point is represented by another complex number z. Now we are going to find the equation of this circle. So in a circle there is a property that radius remains constant, remains unchanged. So radius of the circle, which is modulus of z minus z1, and this will be a constant rho, constant. Okay. Now, if you square both sides, z minus z1 modulus of z minus z1 whole square equals to rho square. Now, there is a property that mod z square equals to z bar. So, you can write this thing as z minus z1 into z minus z1 whole bar equals to rho square. Rho is a real constant, so there is no need of writing rho square as rho into rho bar because rho is a real constant, because radius is always real, or z into z1 into z bar minus z1 bar equals to rho square. Okay, so if you simplify it, you will get this thing z bar minus z1 bar z minus z1 z bar plus z1 bar minus rho square equals to 0. Rho square equals to 0. So this is the form you can write. We can write it as below: z bar plus alpha bar z plus alpha z bar plus r equals to 0. Let me explain what is alpha bar and r. Here alpha is, if you consider alpha as minus z1, then alpha bar will be minus z1 bar, see, and r is z1 bar minus rho square, which is purely a real number, because z1 into z1 bar is a real thing and rho square is real, their difference will also be a real. So this is the equation of a circle. Now, there are some restrictions. When does this equation represent a circle? So let me show you what are the restrictions. Suppose